Okay guys, so continuing from our previous video on reading and parsing CSV, if you haven't watched my first part of the video, please you can subscribe to my channel as well. Check the first video and also the link that is attached to the video below. You can also click on that link to start to see where the beginners for CSV, reading CSV files, parsing date, indexing date, and as well organizing our .csv file started. Now I will continue from the previous video. We've been able to read the CSV as we can see here, and at this point I was able to show just 100 headers, but we can as well so silent this so we don't have too much, but so we don't have too much. And so I can decide. I think I should change the title to reading.csv so that we can know. All right, so now today we are going to see how to use how to make use of each rows, in this case each rows and columns as well. Now, like we already mentioned, we have this is a file containing air pollution of a certain region, and we have a daily reading for this air pollution. This could be either a satellite measurement or otherwise. So now we have PM10, which is quite aerosols. NO2. We're not interested in what is there, but we're just interested in what making use. Now let us see if we can deal with each of those rows. Let us assume we are dealing with just NO. Let's take for example O3. That's ozone. Now we can simply deal with ozone by saying, we can say data, and we can say ozone. It's O3. And so now this time what we're doing is that we are defining the variables inside this data. O3, it's a variable that we have inside this file, and so we are telling this Python to look into this file data that we've already defined, and that to bring out this variable that is defined inside. And just a simple command can, when we print the simple command, it will definitely bring the values of ozone, as we can see, name ozone and the length. And so we can decide to name this, let's just call it ozone, so that we have something nicer. So at the end of the day, now I will print this again. We have, okay, so this time there's what we call indexing in Python. Now indexing has to do with considering a certain rows of this file that we are considering. Now remember, we have 2010 till ending in 2019, which is quite a large data. But let's just assume we are taking out just the first 10, so the first 10 headers, just like we did for the headers. So we can decide to do the indexing. And one thing about Python is that it understands, it starts counting from 0, and so we can decide to say, please Python, index from 0 to 30. And so when we print this, oh, I don't know, I took this out. When we print this, it's going to only show us from 01 to 30th of July, as we can see. So it's going to show us 2010 to on the 30th in this case. So we can decide to play around with whatever we want to use. We can also do the same for as we can say nitrogen, and we can say, I just decided to copy because I'm quite lazy to type sometimes, so I just say NO, as we have the NO2. So we have NO2, and so we can also do the same for NO2, and when we do the same for for nitrogen, we are going to have a quite similar plot. Now this time we have NO2 as the name, and we have also the dots for NO2. Now this is what we can do by considering each rows of this. Now of course we can as well decide to print only a certain number of dates, which we are going to look later also, as a certain the average, the mean of this whole day. But let us see what we can do with this. Now we can decide to say, okay, please let's look for the mean of the whole of nitrogen. Now all we need to do is to say nitrogen dot the mean. Now we can as well define this, say the mean is equal to this, and when we run this, now when we do a simple running again, so we are going to get that the total mean for nitrogen for the whole of NO2, nitrogen dioxide, NO2 was 29.09 for the whole year that we're considering. We can also decide to do similar for we'll just make a copy. We can also decide if we're looking for the standard deviation. What is the standard deviation for this? We can also decide to say STD, because Python understands STD. And so when we do this, we have the STD. We can decide to print, oh sorry, I think I'm using the same mean, so we use STD this time. Come on. So I will take this out. Let's just print both. So we should have, or we can decide to say, okay, when we run this, we should get both the mean and the standard deviation. But to make things more beautiful, one can, or we can also decide to make it more professional by saying Python print. We start by printing this. This is the mean, and we say so that it's more precise what we are doing, make our work look nicer. Oh, yeah, this is the problem with copy and paste. You get quite okay, and can also say this is the STD, just leave it there and say so when we print this, then we have that this is the mean of this and this is the standard deviation. So we can decide to have for this entire column, and so we can decide to have the mean and the standard. We can decide to calculate the standard deviation for each. Now in the case that we are trying to look for the mean of each rows or each columns in group, now how do we solve this problem? How do we write this code? Now we want to remember we have a lot of ways to do this. It depends on what you want to do. We have what we call the group by. Now we can decide to say let's call this total mean, and data dot, we use the group by, then we say data dot index. Now we are indexing the month. We are indexing the month, and this time we are looking for the mean. Let's look for the mean. That's mean. So we can as well decide to also use the same method to look for. And now when we run this, now let's see what we expect to have in this case. Now if we run this code, we're going to have a total. Now we can see that we have the mean for each year. Now we just did the month, the monthly mean. Now it means that it's giving us a mean for 2010, the whole of 2010, one mean. It's for each year, and so we have 12 years in this case, and so that's why we have the index of 12, and we have each mean. So we can also decide to do in this similar manner. We'll just copy and paste this and look for the standard deviation. We can also decide to look for the standard deviation. We can do quite a lot of things with this. Oh, sorry, I'm always using the same. Call this std, and we'll decide to run this again. And so when we print these as well, we are going to have the standard deviation for this value. Now, is it possible to also do a weekly? Because we've been able to calculate the monthly mean. Now let us try to see if we can calculate the weekly mean for this scenario. Now it's as simple as using the same command script, line of command, but this time we'll say underscore. Let's call this weekly. So, and at this time we're using still the index, but this time Python understands week. So we just take out the month and include week. Now what we expect to have in this case is calculating for each year the weekly mean. And so when we print out this, we are going to have, now as we can see, now this is a weekly mean. And remember that for every month we have some 4 weeks, some 5 weeks. And so if we calculate for that 12 years, how many weeks are there in 12 years? We might end up having 53 weeks. And so this is exactly what we have per week. And we can also do the same for a similar thing for the standard deviation per weekly, as simple as just taking out this guy std and running also std. So, and we'll run that. So we are also going to have a weekly standard deviation for all of it. Now there's quite a lot we can easily put up. So what if we are also trying to what if we are trying to find the yearly mean for this these datas? We want to see the mean for yearly of this data. We also do the same because Python understands this. We just say year. Let us make this the mean. And so when we run this, we call it yearly. And so when we run this, we should have the yearly. Now we can see that we have 2010 to 2019. Now we can see that we have PM of each of these. Now now here comes the point. How can we start to plot these this data that we have? Of course, we are going to look at this in our next video. While we'll still continue with some other things that we could play around with finding this data. So guys, like I said, we should have continued, but in our next video, I think we shall continue in our next video, where I will show you how to calculate the relative trends, the regressions, the linear regressions, where we can also use to find the which week it's more polluted, which week is more polluted, which month is more polluted, or which year is polluted, or which year it's less polluted. And we will also do in my next video some basic statistical trends, where we can find for a certain month like January, in a specific year, which day is more populated or more polluted compared to the whole 12 years that we have in this data. Well, I hope you join and subscribe to my channel and wait and watch our next video.